This video will cover section 7.4, which talks about multiplication properties of exponents. Now, we've already talked about simplifying expressions with exponents in them. So for instance, if I gave you x cubed times x squared, then the way we would solve that out is to write everything out. So we have x cubed is x times x times x squared is x times x. Then I told you to count the number of x's, and then that would be the new power, x to the fifth. So what we're looking at today is going from the first thing to the last thing without having to write everything out. So you probably already noticed the rule, but if you look at the exponents here, 3 and 2 separately, and then the final simplified exponent, which is 5, and you can easily see that 3 and 2, when you add them together, make an exponent of 5. So the importance here is if you see both of these variables are the same. So it's an x times another x. And so if you have that, you can add their exponents together. If they were different bases, like an x and a y, you cannot add their exponents. So that's important, is that these have the same base. Okay, so let's look at a different example. Let's say I have x squared, and then that whole thing is being cubed. So in this one, we don't have two separate bases. We just have one base that's raised to a power and then another power. So the old way we did it was x squared 3 times, because cubed means multiply by itself 3 times. And then x squared, so we could further break that up into x times x. Then if you count the x's all together, you would get 6. So this is another rule. If you have a power raised to another power, you will see parentheses here. Then how do I get 2 and 3 here to make 6? Well, simple. You just multiply them. So a power to a power, you multiply to get the final exponent. So the first example, if you have the same base, you add the exponents together. If you have a power to a power, then you multiply the bases together. All right, we have one final example. So if I have 2x, and then that's cubed, so you see here now, the 2 is the coefficient being multiplied with x, not as an exponent as it was in the previous example. So we'll write that out 3 times 2x times 2x times 2x. And then the way you do this is you multiply the coefficients together. So that's 2 times 2 times 2. Or you could think of that as 2 cubed, and then x times x times x, which is x cubed. Then simplify, and you get 8x cubed. So for this example, what you have is you have a product inside parentheses raised to an exponent. So when you have that exponent, it gets like distributed to both of these things inside. So you have 2 to the third power times x to the third power. Okay, so now we're going to put each of those 3 examples together into rules for you. So go ahead and write this down in your notebook, and we're going to have 3 rules. So the first rule is if you multiply like bases. So I want to make sure you're writing down what's happening. You are multiplying. Here our base is a, and you see that you're multiplying them together. So if you are multiplying like bases together, again, they have to be alike, they cannot be different, then what you do is you're going to add their exponents. So here our first exponent is n, the second exponent is m, so then we add them together, n plus m. All right, so multiply like bases, what we do is add their exponents. The second example, we have a power raised to another power. So we have one base, that's a here, to the nth power, and then raised to another power that's different. So we have a to the n and then to the m, and what's going to happen there is n and m will be multiplied. So a power raised to another power, you multiply the exponents. And for the last rule is if inside a parentheses you have a product. So that is a times b. Now it's important here that you make sure it's product and not sum. Only if you're multiplying can you do this. So if you have a product raised to an exponent, then you can distribute that exponent to both parts of that product. So that would be a to the nth power, then times b to the nth power. Notice they're different bases, so they each get the exponent there. All right, so a product raised to a power, we're going to distribute. The exponent. Okay, so what I want you to do with this in your notebook is these 3 rules. I want you to make sure that this pops out to you in your notebook. So I want you to take a highlighter and I want you to put a big box around that, or any marker or anything that'll just make this pop out. So something like that. Okay, so I'm going to move to the next page and we're going to do some examples now with using these properties. We'll start off pretty basic. So we have c to the 4th times c to the 5th. So using our rule, we have multiplication of like bases. So what that means is we're going to add their exponents. So 4 plus 5 gives us 9, and that's our answer. Very, very simple. Okay, number 2. So this example, we have u to the 4th power, and then all that to the 5th power. This is a power to another power. So then what you do is you multiply the exponents. So 4 times 5 is 20, u to the 20th power. Number 3. Okay, this one's a little bit more challenging. So I have 5 times c to the 7th, and then that whole thing cubed. So what I want you to recognize here is that 5 is a number by itself, and it's being multiplied with c to the 7th. So what's happening, I have a product that's being raised to an exponent. So that rule, that's the 3rd rule that we had, which said that if I have a product, this 3 distributes to both of these things. So we're going to have 5. So I'm going to write this one out a little bit further. So I'm going to have 5. I'm going to put 5 in parentheses because that's one part of the product. That gets cubed. And then you multiply by the other part of the product inside the parentheses with c to the 7th, and then that gets cubed. You don't have to write this middle step every time, but I just wanted to show you what's really going on here. So then you say, okay, what's 5 cubed? That's 5 times 5 times 5, which is 125. And then you have c to the 7th and then cubed. So this is a power to a power. So what you're going to do is multiply the exponents to get c to the 21st. And that is the answer. Okay, so these are really simple, but you just need to break them down and go step by step so that you don't make a mistake. Example 4. For example 4, you're going to have to remember PEMDAS. So what you're going to have to do first is what's in parentheses. So you have k to the 8th, and then that's times k cubed in parentheses, and then to the 5th. So what I'm going to do is that k to the 8th, that just stands alone, and I'm going to hold on to that and make that wait until I've simplified k cubed to the 5th power. So the k cubed to the 5th power, that is a power to a power, so I'm going to multiply 3 times 5 to get 15. Okay, so that's the first thing that I do here. Then the second thing is now I have like bases, k times k. So when I have like bases and I'm multiplying them, then you add the 8 and the 15. So again, just to go back, the first thing I did was I have a power to a power, so I multiplied to get 15. And now I have like bases that I'm multiplying, so that means 8 and 15 are going to add to give me k to the 23rd power. Okay, so again, just take it step by step and remember your order of operations. Okay, for example 5, we're really going to take it up a notch, but the same basic rules apply. So now you see there's a lot of stuff going on here. We have variables now sitting inside the exponents, but the same basic rules apply. What you're doing is you're multiplying like bases. You have x times x. So the rule for multiplying like bases is that you add their exponents together. And this time our exponents, instead of just being numbers, are whole expressions, but you still do the same thing. So I'm going to add their exponents together. So the base stays the same, so we're going to keep x down at the bottom. And then if we add, we're going to add like terms. So that is a plus 4a makes 5a. And then 3 minus 2. So make sure you see that 3 minus 2 is plus 1. And 5a plus 1, that's a simplified expression, so we're going to leave it like this. I know it looks really weird, but it's just getting used to applying those rules. So we're going to do a couple more examples with those exponents. So here we have a power raised to a power. So one base, two powers, so those are going to be multiplied together. So I'm going to actually do a middle step here. And so I'm going to say x to the, and then a gets multiplied with a minus 5. And notice I put both of those in parentheses, so I make sure it looks like I'm multiplying them. And so now when I multiply, this first a is going to have to distribute inside those parentheses. That's what you do when you multiply. So a times a is a squared minus a times 5 is 5a. And that's my answer. And we'll do one last example. We'll really step up a notch and really challenge you with the last one. Okay, there's a lot going on with this problem, but I don't want you to be scared of it. You just need to look at each piece separately. So really what we have going on here is a product. Okay, so you see this multiplication here inside the parentheses. And notice that my bases, okay, what's being raised to an exponent, are different, x and y. So that means that you cannot do anything with those exponents together. You don't add them or anything like that because x and y are different. And notice also that 7 is also part of the product. Okay, we don't typically write a dot there to separate the 7, but I want you to understand that 7 is separated as well. So we really have three things that are being multiplied together. The 7 times the x and then times the y. And all of that is being raised to the second power. So if I have a product being raised to an exponent, remember that rule is to distribute that 2. And remember we have that 7, so the 7 gets the 2, or the squared, then the x gets the 2, and the y gets the 2. Okay, so what I'm going to do is I'm going to write this out kind of spread out first. So we have the 7, and I like to separate each of my parts of the product with parentheses. So the first thing's the 7, that gets a squared, times my middle term was x to the 2a minus 3. You see all of that's in parentheses. That gets squared. And then the last thing, the y to the 5a, that gets squared as well. Then we simplify. So 7 squared is 49 times. So here with the x and also the y, we have a power raised to a power. So what we do is we multiply. So we can go ahead and take care of this all in one step. If I'm multiplying 2a minus 3 times 2, I'm going to be distributing that inside that other exponent. So the x is going to be 2a minus 3 times 2. So 2a times 2 is 4a. Negative 3 times 2 is negative 6. Then for the last one, we have the y, which is also a power to a power. It's a little bit easier to multiply here. It's just 5a times 2, which is going to be 10a. Now my final answer here, it cannot be simplified any further. I have no like bases. Everything's as simplified as possible. So this is my final answer. Okay, so the main thing I want you to remember are the rules, and we're going to take this a little bit farther in class.